Another investigative question is based on I think it's glucose, yes, homeostatic process of glucose or blood glucose levels. And the investigation is as follows. They say that an investigation was conducted by scientists to determine the effect of low GI and high GI breakfast on the average blood glucose of women. Note, high GI food is quickly digested and absorbed, and low GI food is slowly digested and absorbed. Now, here I think we are familiar with high GI and low GI foods, and if you are not aware, you can think of the bread that you buy at supermarkets. They're always labeled high GI and low GI. High GI, it means that if it is quickly digested and absorbed, therefore there will be an increase in blood glucose, right? As compared to eating food that is having a low GI, meaning now you'll have less. Basically, let me just say more here. You'll have more glucose in the blood. Okay, let me start over. For this one, if it's high glucose, if it's high GI, you'll have more glucose in the blood, and here you'll have less glucose in the blood. So they say now GI is the glycemic index of a person. Glycemic index is a figure representing the relative ability of carbohydrate food to increase the levels. Exactly. So that's what we are talking about here, increasing the levels of glucose in the blood. So it is clear that high GI food will increase the level of glucose in the blood as compared to low GI food, since they take so long to be digested and absorbed. And if they're not digested, they'll obviously go through the large intestine and they are excreted. Now they say the following steps are followed during the investigation. 10 women who were between the ages of 28 and 30 volunteered to participate, and then the blood glucose concentration of each female was measured before eating the breakfast, and after eating the breakfast the blood glucose concentrations were measured at 15-minute intervals, I believe. So there's the graph of the average glucose levels of the 10 women after having breakfast over 120 minutes, and our y-axis here is our average blood glucose levels after eating. And as you can see at 0 minutes there, meaning they had not eaten, therefore that would say that 4 is their normal blood sugar level or blood glucose level. So 4 is their normal, and then 15 minutes after eating, as you can see, there is an increase in their blood glucose level up until it reaches a certain spike, and now there will be a decrease. So this is where the pancreas or the isolates of Langerhans are able to detect that there is an increase in the blood glucose, and therefore insulin is secreted to do what? To decrease or return the blood sugars, the blood glucose levels back to normal. So as you can see, we said 4 is the normal level. So for high GI foods and low GI, you can see high GI foods are having a very high glucose level, I think around 6, but with low GI you can see that it is close, it's almost close to normal levels. So let's go to the questions and see if we can answer. They say state one reason why blood samples were taken before breakfast was before breakfast was eaten. This is just to compare before and after, just to make a fair comparison before and after. And they say 4.2, give the independent variable for this investigation. Our independent variable is right here. They say to determine to determine the effect of low GI and high GI breakfast. So low GI and high GI breakfast is our independent variable. Low GI, high GI breakfast. That's 4.2. Then we have 4.3. What is 4.3 there? They say give the blood glucose concentration at 45 minutes after eating a high GI breakfast in millimoles per liter. So they say 45 minutes. Where's 45 minutes? Here it is. So you can just trace it, but you are tracing to high what? High GI, and as you can see, it's somewhere between 8 and 9, so I would say 8.5 millimoles per liter, right? Then 4.4. What about 4.4? With reference to the graph, describe the difference between the effect of eating low GI compared to high GI food on the blood glucose level. I mean, it is clear that the high GI have a increase in blood glucose level. There is more glucose. And then in low GI there is less glucose in the blood, since they are GI is the low GI is slowly digested and absorbed, while the high GI is quickly digested and absorbed. So the high GI will lead to more glucose present in the blood, whilst the low GI will lead to less glucose present in the blood. Name the hormone secreted by the pancreas that will increase the effects on blood glucose levels. That will cause, let's read that again. Name the hormone secreted by the pancreas that will cause the effects on blood glucose levels, as seen in the graph from 45 to 120 minutes. So from 45, it's here, to 120, there is a decrease, and that hormone, we know it's insulin. 4.5, that is insulin. We know insulin converts glucose into glycogen and inside the liver, and it will also promote the cell uptake, the glucose uptake by the cells. So that's how it decreases the glucose in the blood. 4.6, explain the effects of high glucose breakfast or high GI breakfast on the secretion of the hormone named in 4.5. They say explain the effect of the high. So basically high GI breakfast, high GI breakfast, what will it do? It will lead to more glucose in the blood, more glucose in the blood, then this will cause what? This increase in glucose will stimulate the islets of Langerhans in the pancreas. To do what? To secrete to secrete insulin. To secrete insulin. Then after that, insulin will convert glucose into glycogen in the liver, and glucose uptake in the cells, then the glucose level will decrease back to normal in the blood. So that's how you explain this whole effect of having high glucose levels in the blood. So the high GI breakfast will lead to more glucose in the blood. This increase in the glucose will stimulate the islets of Langerhans in the pancreas to secrete insulin. Then this insulin will convert glucose into glycogen in the liver and glucose uptake in the cells. Thus, the glucose will decrease back to normal in the blood. That's what we are seeing on this graph right here. So yeah, that's just 4.6. Then they say 4.7, they say 4.7 was this. 6 months later, the scientists decide to repeat the investigation. 5 additional women joined the investigation and were not given breakfast. These ones were not given breakfast, and all as a control group. So control group, we know that this is for what? A fair test. This is for a fair test. So they say what? Give one reason why the scientists decided to repeat. So 4.7a, scientists decide to repeat because they want to increase reliability. They're trying to increase reliability of the investigation and explain the significance of having a control. A control provides us with a fair test, and it also provides us with a validity, fair test and validity. 4.8, they say now, give 2 ways in which scientists ensure the validity of the original investigation. This is by having women of the same age, from 28 to 30, women of the same age, and they also had an increased sample size. So that can also lead to increased sample sizes for reliability. That's not validity. Validity is just to ensure that you are testing for what is supposed to be tested fairly. So women of the same age, as well as blood glucose concentration measured in 15 minutes intervals. Glucose levels measured in 15 minutes intervals, and also glucose levels measured before the investigation. When you measure the glucose level before the investigation, you want to make a fair comparison, so you are increasing validity in that case.